Hello, Algebra 1. Thanks for the feedback on the review thing, and I was glad to hear that you did find it helpful. At least I think the overwhelming majority of you responded and said, yep, that was helpful. So here's our Chapter 10 review. And yep, so just like last time, I have, let's see, well, this time I have 11 questions for you. Some of them are really quick, some of them are a little bit longer. And so I'm going to work through all 11 problems and show all the work and everything, and you can either just do it with me and take it down on your own and have your paper to submit that way, or you can try it on your own and then just look at this video later to check your answers to make sure that you did them correctly. Okay, so here we go. This is Chapter 10 review. Chapter 10 review. Hope you're feeling good about this chapter, at least most of it. Yeah. So number one, our instructions here are, so part A is abbreviating the directions for you a little bit. The PDF will have the full version. State how a transformation of y equals the square root of x, also known as the parent function. Parent function. And then part B, we want to graph it. And then part C, we want to state the domain and range. And here's the equation that we're working with. We are working with y equals square root of x plus 1 plus 3. Now, one thing that I saw happening on the homework is some of you were not paying close enough attention to what is inside the square root versus to what is outside the square root, and that makes all of the difference. Okay? So, our parent function, let me put that up here. Our parent function starts at 0, 0 and goes like that. It's like the top half. I should make it a little bit more curved. It's like the top half of a parabola. Okay? So whatever we add outside of the square root, that will translate up 3 units. So my part A here, I can start out saying translated up 3 units. Okay, when I add stuff outside the square root, that shifts it up. If I subtract stuff outside the square root, that shifts it down. So translate up 3 units. And then the plus 1 here, the plus 1 inside the square root, the effect that is going to have is it will translate it, or I can say translated left, oops, not 3, translated left 1 unit. Now that should be a little bit like, well, to the left, that's in the negative direction. Why would adding inside move us in the negative x direction, but then adding outside move us in the positive y direction? And it kind of has to do with well, let me use this as an example. Just our y equals, let's say, square root of x plus 1 without the plus 3. And if we ask ourselves, what value of x will make y equal 0? Because you agree that this is plus 0, so it's not shifted up or down at all. So the question is our graph shifted to the right one, so it's like that, or is it shifted to the left one, so it's like that? Now, if we ask ourselves, what value of x will make y be 0? Well, y will be 0 when we have the square root of 0. And what x value will give us 0 here, but a negative 1? So it's when x is negative 1 that we will get the point -1, comma 0. And so adding 1 inside the square root makes it so that x needs to be -1 now in order to get y be 0, in order to get y equals 0. Here, back with what we started with, if x is 0, then y will be 0. So we have the point 0, 0. But here, x has to be -1 to get a y value of 0. That's the gist of what's going on with these translations. So that's why adding stuff inside the square root shifts it or translates it to the left, but then adding stuff outside translates it up. Because if I add something outside here, if I modify this one to be y equals the square root of x plus 1, now if x is 0, right, if x is 0, square root of 0 is 0, so then it's got a y value of 1. So here I get the point 0, comma 1, and that's my starting point, and it goes from there. So that shifts it up, okay? So back to the problem that we're dealing with. So translate up 3 units and translate left 1 unit. Hopefully that makes sense. So part B, that gives me what I need to do my graph. So my graph, 3, 1, okay. So usually I have this dot there at 0, 0, but that dot has been moved left 1 unit, up 3 units. And so here at -1, 3 is that dot, and there are no reflections going on. There's no like negative there that would flip it upside down, nothing like that. So from there, it goes the usual shape like that. And that is my graph. And then the domain and the range. The domain is what x values are included on our graph. Well, I have x values starting at -1 and going up from there. So my x values are, my domain is x is greater than or equal to -1. Then my range is what y values I have. So my y value starts at 3 and my graph goes up from there. So I have y is greater than or equal to 3. So my graph starts, for the x values, my graph starts at -1, it goes bigger. Thus x is greater than or equal to -1. For my range, my y value starts at 3 and I go up. I'm going bigger y value, so y is greater than or equal to 3. And that is that problem. Okay? Moving on to number 2. Totally different kind of problem. This is now simplify. And we're going to simplify 3 root 2 times 2 root 6 minus root 27. What I did here is I'm kind of combining some stuff from lesson 2 and from lesson 3 together into one problem. All right, so what I would do first is I would multiply this first part. Now the 3, so multiplication, you can rearrange stuff in whatever order you want. So I would put the 3 times, oh, I wanted blue pen there. So I'm going to do the 3 times the 2. I use that and that. And when I do the root 2 times root 6, that gives me a root 12. Okay, and I'll just see what happens with that. And then I still have this minus root 27 hanging out. So then 3 times 2, that's 6. Okay, root 12. Well, can I pull out something squared? And is there a 2 squared, 3 squared, 4 squared that is a factor of 12? Well, 12 is 4 times 3. And a 4 inside can become a 2 outside. And minus, same thing. Can I pull out a something squared here? Well, 27 is 9 times 3. And 9 is 3 squared. So this could become 6 times 2, because my 4 inside became a 2 outside, because the square root of 4 is 2. And I have this root 3 hanging out, minus, well, the square root of 9 is 3, and I still have this root 3 trapped inside. Now, so this is 12 root 3. I'm going to move this over here. That becomes 12 root 3 minus 3 root 3. which 12 root 3's, and you subtract 3 root 3's, and you're left with a total of 9 root 3's. And that is the final answer. Moving on, number 3. I'm doing dots, not parentheses. Number 3. Same thing, simplify. This time we're simplifying this. Simplify the square root of 16 x to the 6th y cubed z squared. That's all inside the radical. Okay, well, I know the square root of 16 is 4. And then there are two ways that you could look at simplifying these. You could say if it's a square root, you cut the, you cut the exponent in half. You divide the exponent by 2. Or you could view it as this is the same thing. Let me see. Let me put this off to the side and see if this kind of makes sense to you. 16 is, so we have a 4 squared, x cubed squared, because when you do x to the third to the second, you multiply the exponent. So an x cubed squared gives you 6 in x to the 6th. In other words, x to the third times another x to the third. How many total times are you multiplying x? You're multiplying it 6 times. And then the y, well, if I can, I like even exponents. So that's the same thing as a y squared times one more y. And then I have this z squared. Now, anything that is being squared can leave. Okay? So my 4 squared, so my 4 can leave because the squared inside of a square root, the square and the square root cancel, so that leaves me with a 4. The x cubed is being squared, so I can pull that out. X cubed. This, so I pulled that out, I pulled that out. This y squared, I can pull out. Now, and again, anything being squared, what is being squared there but just a y? So I can pull out just a y. This y is not being squared, so it's trapped inside. Or I could also say it does not have an even exponent, it has an odd exponent. And then this z squared, what's being squared there but z, so I can pull a z out. So I pulled that z out. And then what's left? Square root of y. And that is what is left. Technically, this would be an absolute value of x and an absolute value of z, but I'm not going to have you worry about that right now. Okay. How could you check your work here? Well, what you could do is you could take what is here, square it, and take the square root. In other words, if you took everything that's outside the square root and you said, well, let's put it in a, so this is kind of like our check. We're going to take this stuff here that's outside and we're going to put it in a square root and square it. 4x cubed yz squared. And then we still have this times the square root of y hanging out. Well, so I have to square everything here. 4 squared is 16, so I'm still inside the square root here. That's just 16. X cubed squared is x to the 6th. Y squared, z squared. And then I have this y. And when I do the y squared and y, that'll take me back to a y cube, and that will have me matching what I started with. But my answer is this. That is my answer. Next, number 4. This one is one more simplify. We're going to simplify this. 6 plus square root of 10 over the square root of 2. All right, well, what's not simplified here, but we have a square root in the denominator. So how do we get rid of that? If we have just the one square root, we can multiply the top and the bottom by that denominator. I can do this because I'm multiplying by 1, and multiplying by 1 doesn't change what I have. I can multiply just by the root 2 over root 2 because that's the only thing that I have in the bottom. If I had something like this. Let's just say 6 plus root 10 over 3 minus root 2. Now I would need to multiply the top and the bottom by the conjugate of my bottom. So that would be multiplying the top and bottom by 3 plus root 2 and a 3 plus root 2. This would get rid of the radical in the denominator there. But because I just have the one chunk, I can just multiply the top and the bottom by that. So now on my top here, I have distribution that is going to be happening. So 6 times root 2, that's 6 root 2 plus, well, root 10 times root 2, that's root 20 over root 2 times root 2, that is root 4. Okay, now let's see what happens here. I need to check to see if anything can simplify. 6 root 2, that doesn't simplify by itself. Root 20, well, root 20 is the same thing as root 4 times 5. And I have that over, what's the square root of 4? That's 2. Okay. So now let's see what I get. 6 root 2 plus, well, the square root of 4 inside can become a 2 outside, so 2 root 5 over 2. But now I need to check to see if the numbers in front can simplify. Because what happens here is 6 is an even number, 2 is an even number, and we're divided by 2. 6 divides by 2, and 2 divides by 2. So what this would become, and it might be easier for some of you to see what's going on if I split this into two separate fractions. When you have two chunks on top and one on the bottom, you can split it into two separate fractions. So what I have is I have a 6 root 2 over 2 plus a 2 root 5 over 2. That's what I have going on. Now I have this 6 halves root 2. Hopefully you recognize that a 6 root 2 over 2 is the same thing as 6 halves times root 2. If you play it around with just regular numbers, without a square root, you would see that this is totally the same thing. Let's just say I did like 3 times 4 over 2. Well, that's what? 3 times 4 is 12. 12 over 2 is 6. That's the same thing as 3 halves times 4, which what's that? 3 halves is 1.5 times 4. 1.5 times 2 is 3. Double that is 6. This equals 6 again. And this is still the same thing as a 3 times 4 halves. What's 4 halves but 2? 3 times 2 is 6. This equals 6, this equals 6, this equals 6. So you can rearrange stuff. Multiplication and division, it doesn't matter what order you do them. Okay? I should have done that in yellow because that's like what I've been using for kind of side stuff. All right, so all that to say that 6 root 2 over 2 simplifies to 3 root 2, and then we get a plus 1 root 5, or just plus root 5. And that is my final answer there. Made that last chunk too big. That last line cut into my previous line. Okay, that was number 4. Number 5. Number 5, we have solve, and we have 3 root x plus 1 plus 3 equals 18. Okay. So what do we want to do? We want to isolate the radical. Isolate the radical. So first I need to subtract 3 from both sides. So that's going to give me a 3 root x plus 1 equals, not 18 anymore, I'm subtracting by 3, equals 15. Now we can divide both sides by 3, so that gives me root x plus 1 equals 5. Okay, then 2, square both sides. Square both sides. So that gives me x plus 1 equals 25. Subtract 1 from both sides, so this is 3. Solve for x. That gives me x equals 24. That was number 5. And you can do a quick check kind of visually, even if we're not actually taking the time to check it. 24 plus 1 is 25. Square root of 25 is 5. 3 times 5 is 15, plus 3 is 18. So it checks out. Number 6. One more of these, but solve root 2x equals x minus 4. Okay, first step, isolate. And this is already done. Step 2, square both sides. Okay, let's see what we get. That's when I square the left-hand side, I'm just going to get 2x because the squaring gets rid of the square root equals x minus 4 squared. You have to square the whole side. So let's see what we get. X squared. So when I multiply this out, I'll go ahead and do this just in case it's easier for you to see what's going on. So then that gives me 2x equals x squared minus 8x plus 16. And now I need to finish solving. Finish solving. So I have an x squared. So I need to set this up like a quadratic equation with my x squared plus x plus whatever number. So, well, I'm going to subtract. I'll write down what I'm starting with here equals x squared minus 8x plus 16. So I'm going to subtract 2x from both sides. So then this gives me 0 equals x squared minus 10x plus 16. Or, and just because it's easier to deal with I find it, well, I can leave it like this. So we want to, so I have a 1x squared, which means I can do the factoring just by looking for two numbers that multiply to equal 16 and add to equal negative 10. So let's see, 16. 8 times 2 is 16, but I want a negative 10, so I can do negative 8 times negative 2. So then this can factor to be x equals, or sorry, 0 equals x minus 8 times x minus 2. So if x minus 8 times x minus 2 equals 0, then x minus 8 equals 0, or x minus 2 equals 0. And so here we get x equals 8 or x equals 2. Now back what I started with, here's the kind, I had an x squared going on, so here's where I will oftentimes have an extraneous solution. So I have to check my answers with the original formula. So I have square root of 2x equals x minus 4. So I got to check that. So here's our check. I'm going to check first with x equals 8. So I had square root of 2 times x, and now it's 2 times 8 equals x minus 4, so that's equals 8 minus 4. So this is square root of 16 equals 4. Oh, these are question marks because I haven't verified yet. And yet 4 does equal 4. Cool, that one checks out. Let's check the other one, x equals 2. So here I have square root of 2 times 2 equals 2 minus 4. And this is square, question mark. This is square root of 4. Does that equal, well, 2 minus 4 is negative 2. And 2 does not equal negative 2. So this one does not check out. So my one answer is when x equaled 8. That's my solution. All right. I might give you one problem like this on the test for this kind and even more simple versions of it. A more simple version might be something like square root of x plus 5 minus 2 equals 7. Okay, so simpler version like that. You can expect a few of this flavor and probably just one of this flavor. Okay, that was number 6. Number 7. Number 7, we want to find the missing side length. Find the missing side length. And here's the first one that we have. We have this triangle here. This is not quite to scale. This is 12, this is 8, and this is C. So this is a Pythagorean problem. So I know that 12 squared plus 8 squared equals C squared. And so I'm going to go, well, I mean, I know 12 squared is 144. I should be doing this in blue because it's the work that I'm doing. Plus 64. 8 squared is 64. There we go. Plus 64 equals C squared. So 144 plus 64 is 208. So I have 208 equals C squared. So then the square root of 208 equals C. Now I need to check and see if this simplifies. 208 I can divide by 4 and I get 52. So that's the same thing as, let's see, can I divide by 4 again? Yes, I can. So this is the same thing as 16 times 13. So a square root of 16 inside becomes a 4 outside. So this is 4 root 13. That's C. And this is approximately 4 times the square root of 13. Oops. 4 times the square root of 13. That is approximately 14.4. And that's my exact answer. This is my rounded answer. Your hypotenuse always has to be larger than the two legs. So that's always a quick check to be like, does this seem like it's reasonable? Does it seem like if my legs are 8 and 12 that I would get a hypotenuse of something around 14 or 15? Yeah, that seems reasonable. Okay, same kind of problem for number 8. This time, though, here's what we are given. And we know that this is 3, this is B, and this is a square root of 30. Okay. So square root of 30 is my hypotenuse. So when I set this up, I need to say 3 squared plus B squared equals square root of 30 squared. So this gives me 9 plus B squared equals 30, because the square root of 30 squared is just 30. So then B squared equals 21. So then B equals the square root of 21. Now 21 is 3 times 7. And 3 is not a number squared. 7 is not a number squared. So this does not simplify. And then, so then calculator, what's the square root of 21? It is approximately 4.6. Exact answer, rounded answer. That's number 8. Number 9. Number 9 is find the values of the 3 trigonometric ratios for angle A. And here's the triangle that we have. I missed a little bit there. That's okay. This is angle A. Here, I'll do that. This is 12. This is 4, and this is 4 root 10. Okay, well, let's see what I know. Sine of angle A is opposite over hypotenuse, so that's 4 over 4 root 10, which that simplifies to, well, the 4 over 4 simplifies to 1 over 1, so that simplifies to 1 over root 10. But then I'm not supposed to use a square root in the bottom, so I'm going to multiply the top and the bottom by root 10, and that gives me root 10 over 10. So that's my sine. Cosine of angle A is adjacent, so angle A's adjacent side is 12. That's 12 over 4 root 10. Okay. Well, that simplifies to 3 over root 10. Same thing, I ought to multiply the top and the bottom by root 10. And that gives me 3 root 10 over 10. Again, if you want to make sure that you did this correctly, you can use your calculator and you can start with this fraction here. You can start with this fraction here. And on your calculator, do 4 divided by parentheses 4 times square root of 10. And what you get is approximately 0.316. Now I can do the same thing here, and I can do square root of 10 divided by 10, and I get square root of 10 divided by 10. I get, again, 0.316. So it checks out that I simplified it correctly. So you can always check it like that. And one more, tangent. Tangent, oh, so this was an answer. Sorry. I double-clicked to get rid of the select and accidentally zoomed. Okay. Tangent of angle A is opposite over adjacent, so that is 4 over 12, which simplifies to 1/3. There we go. That's number 9. And then number 10 is literally just input on your calculator. So I'll just say like use calculator to find. Let's see. First one is cosine of 304 degrees. Okay, we got to make sure that I'm in degrees, and I am in degree mode, so cosine of 304 is, I was going to do that in blue because this is my work now, 0.5592. And then number 11, same kind of problem, but this time the sine of 212 degrees. And if I do sine of 212, I get negative 0.5299. And that is our review of this chapter and the kind of stuff that you can expect to see on the test. Hope the studying goes well.